extra bright. I want y'all to see this. Turn up the lights in here, baby.
Hello class, sorry I'm unable to be with you today, but I'm at a workshop. But I did want you to have our lesson for today, which deals with using systems of equation, but a process called elimination. So elimination is a process to solving systems of equations by eliminating one of the variables to solve for another. So let's look at our first example. Our first example, we have two equations. The first equation is x minus y equals 3 and 3x plus y equals 1. So when we solve for these systems of equations, we want to eliminate one of our variables. In this case, the easiest variable to eliminate is our y, because we have a negative y and a positive y. And if we add these together, it will cancel out. Now, I'm going to add all the rest of my columns and solve for x. So 1x plus 3x gives me 4x. And 3 plus 1 equals 4. Now, in order to solve for x, I have to divide by my 4 on both sides. So x equals 1. I'm not done yet because remember we've talked about how systems is a set of ordered pairs with an x and a y. So in this case I have my x, but in order to solve for my y, I have to substitute an x back in my equation to solve for y. I'm going to use the top equation. You will get 1 minus y equals 3. Here I have substituted what I found for x in place of x on my top equation. Now solving for y, I get, subtract 1 from both sides, I get negative y equals 2, but I'm still not done because I have a negative in front of my y. So dividing by my negative 1, I get y to equal negative 2. Now in this case, I have an x and a y, and I can find my solution or my intersection point to be 1, negative 2. Looking at my second example. Here I have 3x plus 4y equals 6, and 5x plus 2y equals a negative 4. In this case, I don't have anything that I can automatically eliminate. So I want to look and see where I can multiply by something in one of my equations to make one of my variables disappear. In this case, I'm going to multiply my second equation by a negative 2. When I do that, that's going to eliminate my y. So taking my second equation, I'm going to multiply by negative 2. I multiply everything in my equation just like I have for my distributive property. So I'm going to have my new equation to be negative 10x plus a negative 4y equals 8. Now I can kind of cross this equation out because I'm finished with it. Now I want to use my top equation and my bottom equation. When I add those equations together, I get negative 7x. My y's have now gone away, and I get equals 14. Dividing by my 7, I can solve for x. So in this case, x equals negative 2. Now I still need to solve for y because I do not have an ordered pair. So I take my x equals negative 2 and I'm going to substitute it back in my top equation. Doing that over here, I get 3 times a negative 2 plus 4y equals 6. I get a negative 6 plus 4y equals 6. Adding 6 to both sides. Then I get 4y equals 12. Dividing by 4 on both sides, I get y to equal 3. So my solution for this systems of equations using elimination is negative 2, 3. And for our third example, we still want to eliminate one of our variables, but in this case there's nothing that we can eliminate. that's easy to see. So what we're going to need to do is we're going to need to multiply by something for our first equation and our second equation. So we're going to eliminate the x in this case. So we're going to multiply our top equation by -2 and our bottom equation by 3. Doing so, I'm going to write my new equation down here. So -2 times 3 gives me a -6x. -2 times 4 gives me a -8y. And -2 times -25 gives me a +50. Multiplying my bottom equation. 3 times 2 gives me 6x. 3 times a -3 gives me -9y. And 3 times 6 gives me 18. Now I have something that I can eliminate. So in this case, I'm going to eliminate my x's. Now, -8 plus a -9 gives me -17y, and 50 plus 18 gives me 68. Dividing by my -17, I get y to equal -4. Now, I still need to substitute that back in one of my equations. So I'm going to substitute it back into my top equation. Doing so, I'm going to do that right over here. We get the answer to be 3x plus 4 times a -4 equals -25. Then, multiplying here, we get -16. 3x equals a -25. Adding my 16 to both sides, I get 3x equals -9. And now dividing by 3, I get x to equal -3. So my ordered pair for my solution is going to be -3, -4. My x value and my y value. Now, going on to your last example, we have a real-life application word problem. So, I'm going to read the problem. The Finneytown Bakery is making peanut butter cookies and loaves of quick bread. The preparation and baking times for each are given in the table below. For these two items, the management has allotted 800 minutes of employee time and 900 minutes of oven time. If C represents the number of batches of cookies, and B represents the number of loaves of bread, the following systems of equations can be used to determine how many of each to bake. So you need to look at your table, and we need to decide on two systems of equations. So for example 4, we should have and create two systems of equation. So we know for preparation, we have 20 minutes for cookies, 10 minutes for bread, and all of that together needs to equal 800 minutes. So our first equation should be 20C plus 10B equals 800. Then our second equation, we know that we have 900 minutes of oven time or baking time. So 10C plus 30B equals 900. Now, we need to choose which method is going to be best to solve. In this case, I'm going to choose elimination because I can easily remove this by multiplying my second equation by -2. Now that you have your equations and know what method to use, try to solve this problem on your own. You also have 10 extra problems to try for your classwork. You need to make sure that you understand how to do those because you will have a quiz on Friday. I will see you Friday.